Okay, we want to find the volume of the smaller wedge cut from a sphere of radius A by two planes that intersect along a diameter at an angle of pi 6. Okay, let me attempt to draw this thing for you. Let me move down a little bit. So first I'll start off by drawing a sphere. Okay. To make it look like a sphere, I'll put in an equator. There we go. Okay. And then I'll put in some coordinate axes. The z-axis. There's z, and then this will be the y-axis. And then the x-axis will come out like so. Okay, so we want to cut a wedge out of this sphere using two planes where the planes intersect along a line and they form an angle of pi over 6. So the way to draw this, okay, I'm just going to draw the cross section formed by the plane and the sphere. So one plane there's no loss in generality. I can draw it so that it contains the z-axis, and which corresponds to a diameter of the sphere. If you go from up here to down here, that's a diameter of the sphere, and the cross section formed will look like this. Okay, and then take another plane that's at an angle of pi over 6 with the previous plane. It also contains z, and it forms an angle of pi over 6 with the previous plane. What does the cross-section look like with the sphere? Well, it might look something like that. So what we're interested in finding here is the volume of the wedge cut out from the sphere and its interior. From this space in here, the smaller wedge, of course. Okay, so hopefully it's clear that we're going to use, let me give that wedge an outline. Hopefully it's clear we're going to use spherical coordinates here. Okay, so set up your template integral. It's a triple integral. Rho squared sine phi is automatically part of your volume element in spherical coordinates. D rho, d phi, d theta. Okay, so let's find the inner limits of integration first. What is rho going to range from? Well, rho will just range from 0 to out to the edge of the sphere, and we know that that's the radius of the sphere is a. So rho goes from 0 to a. Inner limits of integration from 0 to a. Phi, well, okay, phi, remember, phi equals 0 in the direction of the z-axis, and then we have to, so in this, well, it's not showing up very well. So let me try this color. In this direction, up this way, phi is 0. But phi has to range from phi equals 0 to all the way to cut out, to sweep out the entire wedge. To sweep out the entire wedge, we have to go all the way to the negative z-axis, which as an angle is pi. So phi has to go from 0 to pi. And then theta is going to sweep out in order for theta to sweep out the wedge, we need theta to go from 0, which corresponds to this part of the wedge, the left side of the wedge, to all the way over to here, the right side of the wedge, and we know that that angle is pi 6. So theta goes from 0 to pi 6. So that's your setup. Now notice all of the limits of integration are constant. The functions of rho and phi are separable. So I'm going to write this triple integral as a product of 3 integrals. The integral from 0 to pi 6 of, okay, there is no function of theta, so just d theta, 1 d theta if you prefer, times the integral from 0 to pi sine phi d phi, times the integral from 0 to a rho squared d rho. And the beauty of doing it this way is you can just evaluate each integral separately. Okay, the integral from 0 to pi over 6 of 1 d theta is just pi over 6. If you integrate sine of phi, I think you get negative cosine phi, and you have to evaluate that from 0 to pi. And then the integral from 0 to a of rho squared d rho is just, well, it's going to end up being a cubed over 3. If you go ahead and well, integrate, you'll get rho cubed over 3, and then evaluate, you'll get a cubed over 3. So now, let's see, what have we got? What have we got? We've got pi times a cubed over 18, if we multiply these guys together. And then if we evaluate this, well, okay, if you plug in the upper limit, I think you get the opposite of the cosine of pi, but the cosine of pi is negative 1, so you get the opposite of negative 1, or just 1. And then minus, if you plug in 0, okay, from this negative, it's going to be negative, and the cosine of 0 is 1. And then this negative is from the fundamental theorem of calculus. So you end up with just 1 plus 1, or 2 altogether. So this thing right here, this whole thing right here is 2, so that when you multiply it times the pi a cubed over 18, you just get pi a cubed over 9. Cubic units, so that's your volume.